Hello, my name is Rhea Vashishtha, and I'm 17 years old. I live in Washington, and I did my project on the design and control of 3D printed and actuated prosthetic hands. And my project is to build a 3D printed prosthetic actuated hand and create a website that presents my research. My name is Rhea, and I'm 17 years old. I'm from Bellevue, and I'm a tennis player. I chose to research prosthetics because I think that the issue is something that's very unique, and it's really interesting, and it's often overlooked as well. So, what exactly is a prosthetic? So, prosthetics are substitutes for a missing part of the body that might have been lost during birth or lost in an accident or through amputation. So there's four kinds of prosthetics. There's transtibial prosthetics that go below the knee. There's transhumeral prosthetics, and they go between the shoulder and the elbow. And there's transradial prosthetics that attach below the elbow. And lastly, there's transfemoral prosthetics that attach above the knee. So for my project, I'll be working with transradial prosthetics, and they're going to be prosthetics for children specifically. So as you can see, I have some pictures of each of the types of prosthetics for you to look at. So I'll be working with the hand one. Okay, so what exactly is the problem with prosthetics as of now? So for one, they're pretty inaccessible, especially to children in underserved areas since they're so expensive. Also, in case of children, since they grow so quickly, prosthetics, they have to be easily adjustable for them. The prosthetics also have a tendency to be quite bulky, which makes them pretty difficult to remove from the connection point, and they can also be really hard to control when they're being worn. The reason that prosthetics can be bulky is because of the amount of motors and circuitry and electronics that are required for it to be functional in the first place. So the interior components of this prosthetic take up a lot of space, and it makes it very heavy and bulky. So it's just like a huge hassle to move around, and oftentimes it demotivates the user from actually using the prosthetic limb. And finally, in terms of engineering design, one of the biggest issues that's faced is mimicking the human thumb, because we have such a wide range of motion in our thumb. Our thumbs are actually what allow us to grip obscure objects and manipulate them firmly. So recreating the same degrees of freedom in an artificial limb is like a huge obstacle that researchers have been trying to surpass for many years. So, what are some possible solutions? So using 3D printed materials could make prosthetics more affordable. For my project, I'll be using carbon fiber filament, which is relatively cheaper compared to a lot of other materials. Additionally, I'll be using small reduction stepper motors in order to attempt to make the prosthetic less bulky. And lastly, using computer-aided drafting will allow for quick changes in measurements so that adjustability is simple. Also, over the years, researchers have found ways to innovate prosthetics to overcome some of the obstacles and constraints they faced. So in the kit prosthetic hand, as shown in the top left, it's gripping in orange. It uses a technique of under-actuation to increase control and grip of obscure objects. Research over the years has shown that the pulley system allows for a balance between control and power. So basically, it's a under-actuated way to increase control, but also not make the hand too bulky. So it's like more limber, but can also provide the correct amount of control. Lastly, if you look at the top right, you can see that Johns Hopkins created a fully actuated prosthetic hand or arm actually in 2010. but it was actually a $10 million investment, and it's not feasible to produce at a large scale, and it's definitely not able to help people that are in impoverished areas. Okay. So what exactly am I doing? So I will be building a 3D printed actuated prosthetic limb. I'm focused on the issue of children in underserved areas not having access to prosthetics, and I'm researching mechanisms that will help create affordable, adjustable, reliable, and usable prosthetic hands. And in order to build the prosthetic, I will be using SolidWorks, which is a CAD software, to model each individual segment of the finger, thumb, and the palm. I will be using a Prusa 3D printer to print the parts modeled on CAD, and then I will use a multitude of electronics and motors to actuate the prosthetic. I will also be creating a website to show my work and innovation, so that is a work in progress right now. That is, as you can see on the slide, that is the printer that I used, and on top of that is just like a model of the motor in CAD. Yeah, so these pictures here are some initial design sketches that I made before formally modeling them on CAD. So the idea is essentially like how the mechanism of my prosthetic works is to use a fishing wire. The idea is to use a fishing wire and axles to create a pulley system, as I was talking about earlier, that will allow the hand to open and close. So the two pictures on the right-hand side of the slideshow show the side view and a top view of what the finger will look like put together. There is an outer shell, and on the inside there's a hook made for the fishing wire to wrap around. And on the left side of the slide, you can see the motor placement. So the stepper motors will attach to the fishing wire, which will allow it to move up and down so the hand can open and close. Having a motor for each individual hand will allow for more movement, of freedom of movement, rather than having one for all 4 thumbs and then just having one for the thumb. However, having the 5 motors rather than 2 motors creates a problem in which where the hand will be more bulky, but that's kind of a trade-off that I'm going to have to make, even though I tried to account for the bulkiness with using a pulley system. But yeah. Okay, so the pictures that you see here are CAD models of each individual segment of the finger. So in the top right is the fingertip, and you can see that there's a hook for the fishing line, and there's an axle that it will run over so it doesn't get tangled. In the top left is the middle of the finger that also hooks onto the axle, but it uses hooks to hold onto the axle, but also the hooks allow for some degrees of freedom, so it's easy to move. And finally, the bottom left is the bottom of the finger that will attach to the stepper motor. Thank you so much. I plan on modeling the palm soon, and then starting the process of 3D printing and actuating. This is the end of my presentation. Thank you so much.
Great. Any questions for Rhea? Rhea, sorry. I will start with one. What are the current range of costs for prosthetics arm? You mentioned that you're trying to create more accessibility.
Yeah, so right now, like some of the things are like the cost of building a prosthetic is like to create a prosthetic, there's like there's a wide range of like how effective the prosthetic is. It depends. So how high tech the prosthetic is and how usable it is depends on like that affects how costly it is, basically. So like, for example, a fully actuated one was $10 million to create, which is like insane. So there's that. Building like a regular one can also cost up to $20,000, something that someone like maybe in the United States would use if they have like an amputation or something, those can cost up to those can cost like thousands of dollars as well. So that's something that people in underserved areas or war-torn countries that actually do need prosthetics, they can't really access those because just getting the materials is really hard, and since they're overseas, it's even harder. And the materials already cost more, and then them being all like in a place where they're hard to get is even harder. So that just like increases the cost even more.
Got it. And tied to that, what do you think, given those cost constraints for places that really need it, what do you think the reasonable set of, motor features would be that you'd be trying to get for a prosthetic?
Yeah, so actually the motors that I'm using right now for my prosthetic, they're literally like $5 each. So like trying to use something that's that like accessible, like they're super, like you can literally just go to like a Fry's or something and you can get, or like a Lowe's, and they have them and they're super accessible and they're very small. They're about like this big. They yeah, so those are the ones that I'm trying to use. They're stepper motors, so they just go kind of in a semicircle, so they can open and close the hand, and you can use programming to make them go to a certain degree, and using touch sensors and a whole bunch of stuff, you can make them like grip cool stuff, and it'll So, and they also provide enough power to like actually like hold things.
Yeah, that's a good question. How much power do they need to be recharged at some cadence?
I don't know. I haven't like gotten to the point where I can actually like I've built the whole like part on CAD, but I haven't been able to 3D print it quite yet. So I don't know how the actuation is gonna fully work, but I know that these motors actually, let me see. I have them right here. Yeah, I don't know. I'm not sure. It's a good
Okay.
question though. I should look at that. Yeah.
Two last questions for you, and they're kind of tied together, so I'll ask them both at once. What makes the materials much more expensive for the pricey prosthetics? And how did you choose your materials other than cost? Were there any benefit comparisons you made?
Yeah. So first of all, the materials that are really costly, it's not only just the materials, but it's like the way they build the materials are like, for example, the 3D printer I'm using, I chose to use because it's the most efficient. Like I had to build the 3D printer myself to make it like kind of customized so I can like do the work how I wanted to do it. But the 3D printer that I had is an FDM printer, which is the most accessible for for a person like me, or like anyone who's like using using a 3D printer for like hobbies or just like for research of their own, because it's not an industrial level printer. So FDM printers are usually like less costly, which is like one of the ways I'm trying to decrease the cost of prosthetic overall, because they use carbon fiber filament, and carbon fiber is pretty like it's like pretty it's not super cheap, but it's like way cheaper than all the other materials. So the thing that makes the other prosthetics way uh way more expensive is the 3D printing. If they're using 3D printers, um it's really expensive because they use industrial grade 3D printers, which can not only print carbon fiber, but they can like literally print metal and like steel and so many other things. So that really increases it. Most of the time they're not FDM printers. They're like they might be like different kinds. There's like 3 different kinds of printers. Um, and they could be using like the more industrial like professional level ones. There's also the fact that if they're not using 3D printing, then that just increases the cost even more because they're having to like create all the parts on their own. And yeah, so that's kind of what makes it like really expensive. And also the fact that people haven't found out a complete way to make prosthetics super usable, which is like the whole problem, which increases costs, which drives costs up a lot. So yeah.
Great. And then one last question came in, and I think also tied to it. What's your estimate for durability? How long will the prosthetic and the parts last, and how are you accounting for wear and tear?
Yeah, so is this asking about like the prosthetic I'm creating?
Yeah, I think
Yeah.
so.
Okay, so well, one of the cool things that I did is, so since this is for like I did like my research in terms of making this for a kid. First of all, kids are reckless and they do stuff and like break stuff all the time. And so I carbon fiber is generally pretty it's pretty tough. It's also quite flexible. So unless the kid literally goes in and breaks it, it won't break that easily. And the other thing is that the best thing about FDM printers is that the filament doesn't melt. Like if it goes out in sunlight, it won't just start like deforming, which is really nice. Because a lot of other printers have that problem, or a lot of other filaments have that problem. So there's that. It's pretty durable, but also if it does break, in the case it does break, the best part about 3D printing is that you can just go in and print another one. It won't take more than a few hours. And also, if the kids, because the kids grow, you have to adjust the size of the prosthetic. So you can literally go into CAD and you can take if I can like go back and show you. So like these like segments on the side, you can just you can just take the measurements and increase them and decrease them depending, and then readjust whatever, and then reprinting. So that's how I kind of accounted for durability in terms of that. Yeah.
Incredible. Thank you.